everyone! So in this tutorial I wanted to show you not only how I made this shoe, but also how to approach this kind of problem, how to analyze real-world cases and how to implement solutions inside of Blender. Also, this tutorial will be two-part series because when I recorded everything and see how much material I have, I decided to divide it by two. So the first part will be about creating this 3D pattern, and we will just use default cube for that. And in the second part we will modify this geometry node setup to enable it working on any given mesh. And today's tutorial is inspired by this comment. So the first thing that I do is to Google what the Adidas Futurecraft 3D look like. As you can see, it's two different 3D patterns, and after finding the Carbon 3D website, I can examine the story behind this pattern a little bit more. As you can see, we have 4 different patterns in the cube-like shape, and this is my main inspiration for the workflow, so I choose the top left corner pattern to recreate. So the next thing that I need to do is to analyze this pattern to recreate something similar in Blender. So as you can see, we have the first layer, the diagonal cross pattern, made of crosses, and at the middle of the connection between each cross we have another connection to the cross in the next layer. So this is our first task to do in Blender, recreate something like that from lines. We also need to remember that at the end we want to recreate a shoe sole, so we need a re-adaptive geometry node setup that can work in any given shape, not just a cube. But let's focus that later. Now we need to recreate this 3D pattern, and to make it easy, we just make the cube. Okay, so let's jump into new blend file and start making this shoe. Okay, so let's delete everything except for our default cube, and let's jump into Geometry Node tab. Let's add a new Geometry Node network and call it maybe shoe sole. Okay, so you can see this pattern is evenly distributed in 3D space. So between each next nodes it's even distance. So we need to distribute evenly points in space. And we can do this extremely easy in Blender by converting any geometry to volume using mesh to volume node. And we need to change a few settings. First we need to set exterior bandwidth to 0. Exterior bandwidth basically will scale our geometry in normal direction, making volume equally bigger than our input mesh. So let's set it to 0. And let's increase our resolution by changing voxel amount from 64 to maybe 256. If you're working on the slower machine, this tutorial might be a little bit hard. We can turn off the timing option to see how much time each node is computing. As you can see, it takes 320 milliseconds. So for now, let's maybe change it to 128. And as you can see, 88 milliseconds, much quicker. We can increase density so we can better see our volume. This will be much more important where we're actually using shoe sole geometry, not the default cube. And now we can distribute evenly points using distribute points in volume. As you can see, they are not distributed evenly because the setting by default is random, and we need to change it to grid. Okay, now we create the most important value in our geometry node setup, and this will be the scale of our 3D pattern. We have the spacing option here. As you can see, it just changed the distance between our points. Okay, so let's create the value node. And this value node will be the scale of our 3D pattern. So let's rename it by pressing F2, scale. Let's connect it to our spacing, but let's change the value to 0.2 and connect it to our spacing. As you can see, now we can control the spacing between our points. Okay, so now you create safety mechanism, because if you set the value to too low, it will probably crash Blender. So let's use the switch node here, and for the condition we'll use greater than node. Let's change it to float. Plug it here and set it to 0.1, this also to 0.1, and let's plug it here. And what it will do, each time if our value is smaller than 0.1, especially the 3 small numbers, it will switch to the 0.1. So we can't go under 0.1, which is really good. Okay. So let's set it to something bigger. And now we have evenly distributed points in 3D space. I will close this and this to have a little bit more space here. Okay. So let's look at our cube pattern once again. So as you can see, the first layer of the pattern is basically this tiny axis scattered diagonally. So what we need to do is to make this point diagonal, because now if I would scatter axes, as we can see, they are next to each other. And what we want to do is to have this kind of pattern. So let's start by moving these points. Let's increase density a little bit. And let's duplicate this distribute point in volume node by pressing Ctrl-Shift-D. Now we need to add set position node and join node between these two. As you can see, nothing has changed because everything is now overlapping. But what we want to do is to create an offset that will look like this. Thanks to that, as you can see, we have diagonally scattered points. And we of course doesn't want to use static hard-coded values here, because we won't have dynamic scale. If now I would change the scale now, as you can see, everything falls apart as soon as I change the scale. So to fix it, we need to use scale value here. So let's drag it and use reroute node to have better node management. And now what we need to do is to use combine XYZ node. Thanks to that, we can connect float values to vector input. And let's think for a moment what we need to do. Let's preview our original distribute points in volume. And what we need to do is to create points between exactly in the middle of each foregroup of points. So we need to have offset by this and then this. And this value is exactly half of our scale, and this value is also half of our scale. And what we need to do is to just use the multiplied node and multiply it by half. So let's drag and search for multiply and plug it to X and then in Z. Now plug it to offset and let's preview it. And as you can see, we have our diagonal pattern. And if I change the scale now, as you can see, everything works perfectly. Let's frame it so we will be organized. And now we need to scale this little axis. So we need to create geometry that we will later instance on these points. And as a base geometry, I will use the star node. So let's search for star. And let's preview it. And as you can see, it's a star and it's also curve type. So let's change the points number to 4. And let's change the inner radius to 0. And as you can see, now we have our cross geometry, but we need to play it with to create right dimensions for that. Okay, so first let's look a little bit closer to our distributed points. And as you can see, this is our scale. We want to calculate the radius, and we need to do this based on this scale. We want to scatter the new geometry here, and it will look like this. Here is our radius that we want to calculate. So to calculate this, we need to this dimension, and this will be exactly half of our scale. If you look a little bit closer, you can see that the half of the scale is also here. So we basically have a square, and 2 times r is the diagonal of that square. And to calculate our radius, we just simply use Pythagoras. And after a little bit of math, here is our result. So let's first use reroute node. And before we actually calculate the right scale, let's rotate our star, because now we have wrong rotation. So let's use transform node and let's rotate it in the z-axis by 45 degrees. As you can see, now we have right rotation that match our pattern. So to calculate the scale, we will do it in two steps. First, let's multiply it by half, which is equivalent of divided by 2. And now let's divide it by square root of 2. And thanks to that, we will match what we calculated before. So to actually use the square root of 2, we just write sqrt and inside the brackets 2. Blender will actually calculate the right number. So now we just need to connect this to our outer radius. Okay, so after creating this geometry, we need to scatter this on our points. So let's use the instance on points node and plug this as our instance. Let's look from the front and we need to rotate it in the x-axis to see the result. I will rotate it by minus 90 degrees. And as you can see, we have our diagonal pattern, which is exactly what we wanted, and it works perfectly with our scale. But now, this is completely two-dimensional, and as you can see in our example, we have a third dimension in our instances. So we need to move the central point of this star in the z-axis. So let's use the set position node, and we need two things. First, we need the selection to move only the center part, and then we need the offset. So for the selection, we just use the outer points for a star, but when I plug it directly, as you can see, we change the position of the arms, not the center. So let's use the not node, and that will inverse our selection. Now we are changing the middle part. So the offset could be pretty much to your own choice, but I would like to combine it with our scale, and I would like to set it to be a third part of this dimension. So let's use scale from our reroute node, and let's divide it by 3. Let's move everything a little bit higher to have more space. And now with combine XYZ, we have our offset. The last things we need to do is to use merge by distance node, because we have overlapping geometry here, but as you can see, we have an error, input geometry has unsupported type, so let's convert this curve to mesh. And now we have everything that we need for our instances. So let's change the instance input and let's see the results. As you can see, the pattern is now three-dimensional. Let's check if scale working. As you can see, everything worked perfectly. So we have the first layer of our 3D pattern. But if you look for the side, this is not connected at all. And let's look for our example. This is the first layer of our 3D pattern, and as you can see, at the connection point between the instances, we have another connection to the layer behind. And we need to create this connection between each layer. So if you look for the side, we need to create geometry that will start from these points and will be connected to these points. So we basically need to create something like this. And this connection must be in between each layer of our 3D pattern. So the first things we need to do is to create some points that we can scatter later on our new instances. So let's back to our points. So when we look from the front, here we will have our instances. And our new geometry must be exactly between. So we need to create the point that will be between this. So let's create that first, and then we will think where our point we need to be from the side. So let's duplicate our distribute points in volume by pressing Ctrl+Shift+D, and to get it out from the frame, let's press Alt+P. Now let's use set position node, and let's join it with our previous points to better see what we are doing. So let's add join node, and let's play with the offset. Now we have the problem that we can easily get confused which points is which. So let's change the scale of our new points by using set point radius. Let's choose maybe something like this, and now we can clearly see which are the new one. So as I said before, we need points here, but we also need points here. So we can clearly see that we need more points. So let's duplicate this free node, and let's create the new join node to keep things clean. Now we can change this value. Okay, so now we see that this point will need offset in the X direction, and this point will need the offset in the Z direction, and it will be the same value. So what value it will be? Let's think about it. So we know that this is our scale distance, and the offset one again will be the half of the scale. We already calculate this here, so let's maybe get out this from the frame by pressing Alt and P and move it here. Let's maybe frame it and call it half scale. To make it even more visible, we can change the color of the frame under N panel, and we can even increase the label size. Okay, now we have two main variables, scale and the half scale. Let's use reroute node to have a little bit cleaner nodes. And we have the problem because this actually should be after switch. Okay, so now we can use this half scale in our set position. We only need one more node, combine XYZ. So here we need the X offset, and here we need the Z offset. So let's switch inputs. Okay, let's test it with our scale. And as you can see, everything works perfectly. Okay, so the last offset will be in the Y direction, and we need to offset every single point of our new groups in Y by just a half of the scale. So let's again use the half scale and plug it into the Y offset. Okay, now everything looks perfect. So now we need to create the new instances that we can scatter on this point. But first, let's frame it, selecting it and pressing Ctrl+J. Okay, so to create the new instances, I will actually duplicate the creation of the first one, because it's a great base for our new instance geometry. So let's select it and press Ctrl+Shift+D and move it below. Okay, and now let's think what we actually need. So we basically need to mirror this geometry to create the connection between our existing layers. So this dimension will be exactly the scale. So as you can remember, for our instance geometry, we used 1/3 of the scale as a height. Now we need to change this value to 2 because we need a half of the scale for our height. Now let's use transform node here. And let's rotate it in the Y by 180 degrees. Now we need to join these things together. As you can see, now we need to offset the bottom part to the top to create the X shape in this view too. So let's duplicate the transform geometry and reset rotation to 0. And now we need to offset it exactly for the value of scale. So let's use combine XYZ node. And here we have our scale value, so I will use this and plug it to combine XYZ, and let's plug it to translation. As you can see, we have perfect shape now. The last things we need to do is to use merge by distance node, so let's duplicate it and use it here. Okay, so the last things that we need to do for our instances is to set the origin point here. And to do this, we can use simply set position node. Now we need to combine XYZ node. We can take it from here. And we need to create negative offset in the Z value. And this will just be the half scale, but multiply by -1. So let's take it, multiply it by -1 and plug it to Z. Okay, but why we need to change the origin? Because when we go back to our points, the small one are the connectors and they will need to connect the layers of the geometry. So the X must be exactly in the middle here. So if we would not change this origin, they would be scattered like that. And this is not what we wanted. So that's why we need to change the origin. So now, finally, we can scatter instances. So let's duplicate the instance on point node by pressing Shift D. And this will be our points. And this will be our instances. Let's preview it. It looks nice. And let's join it with our second instances by using join geometry node. And as you can see, everything looks okay. Let's make a little order here by framing nodes. So this will be our layers geometry. This will be layer points. This will be connector points. And this will be connector geometry. Okay. The last issue, if you look for our reference, as you can see, the first layer is the standard geometry node layer, not the connectors. So we can offset all of the connectors or of the base geometry to create this result. Because as you can see, now the first layer is the connectors. So let's use set position nodes for this. And as you can see, we need to offset it exactly the scale in the Y direction. So let's use reroute node, drag it here, maybe let's use another reroute, and we need to combine XYZ node here in the Y axis. Let's plug it, and as you can see, everything is now working correctly. We can even change the scale, and everything works as expected. Okay, so the hardest part is done. Now we need to create the real geometry, not just lines. So as you can see on the references, it's pretty organic shape. It's not this real geometry tubes with perfect connections. It's pretty organic. And we can recreate this effect in Blender. It will be pretty heavily in terms of number of vertices and the time to calculate in geometry nodes, but the end effect is really nice. So the first things we need to do is to realize our instances. So let's use realize instances node. And now we need to convert it to curve. So let's use mesh to curve node. Now we need to add thickness to each of these lines, and we can do this really easily by using curve to mesh node. This node will allow us to add profile curve, and we use the simple circle for that. We don't need 32 resolution because it's clearly too much and the computation time will take forever with that amount of resolution. I think the 5 is completely enough. If you don't like the effect, you can always try to increase this, but the 5 is enough in the most cases. So let's plug it here, and as you can see, it's really weird. And this is because the radius is much too much. So let's maybe create the input, group input node, and now we have radius variable. Let's change it to something small like maybe 001. And as you can see, it looks pretty good, maybe a little bit thicker. Okay, now I would like to create this organic effect. So what I need to do is to convert everything to volume. So let's use mesh to volume node. And here we need to change some parameters. First, let's change exterior bandwidth to 0. As you can see, it doesn't really resemble the input mesh, and this is because the voxel amount is much too small. I would like to set it maybe to 800, and this will take a moment to compile. And as you can see, it looks pretty good. We can increase density to better preview the result. And let's convert it back to mesh using volume to mesh. As you can see, we have some problems. It doesn't really look very organic, and to fix it, we'll use blur node. So let's first add set position node. If your calculation time is too long, you can turn off the viewport visibility for now. Let's add position node and blur attribute. And this basically works like a smooth modifier. So this is the iteration of smoothness, and I think something around 40 works pretty well, but you must keep in mind that often we will need to increase the radius for this. So let's plug this into position and wait a moment to calculate. And as you can see, it looks much better, but we need to increase the thickness now, maybe to 4 centimeters. And as you can see, it works really weird on the connection, and this is because we need to check the fill caps in our curve to mesh. So let's check it, and now it looks much better. As you can see, it starts looking pretty good, but what I don't like is this weird moment at the connection point. And this is because when we go back to our curve to mesh, as you can see, we literally have kind of hole here. And to fix it, we can scatter some geometry on the connection point, and I think we can scatter simple UV spheres here. So let's create UV sphere node, and for radius, I will use the radius input. Again, we don't need that much geometry. I will set it for 8 and 4. That's completely enough. Now we can use instance on point node, and this will be our instance, and as points I will simply use the realized instances geometry. So let's plug it here and let's preview the result. Okay, now we need to realize this geometry, so let's duplicate this node and let's join it before our mesh to volume. We can maybe move it a little more, and let's add join geometry node. Let's preview it and join with this. And as you can see, now we have this geometry exactly at the connection point. Okay, so let's plug this joint geometry to our mesh to volume and let's preview the final result. Okay, and this looks pretty good. Okay, so this is our current result. This is our base pattern, and you can customize however you like by changing parameters and play with the input pattern. After playing a little bit more with geometry node setup, I find out that if you want to make the pattern even more organic, you can actually decrease the resolution in the mesh to volume at the end. I decreased it to 400. Also, you can increase the number of iteration in blur attributes at the end of our network. I increased it from 40 to 90. And you must remember that if you change this, you also need to increase the radius for our geometry nodes pattern. So this will be it for this part of the tutorial. In the next part we will be working on how to transform this default cube to our final shoe. Okay, so thank you so much for watching. I hope you learned something new, and if you want to know when the next part will be released, you can always subscribe. Thanks for watching and bye.